So in our last section, we talked about how we would actually control a dynamic ground space layer combination. And so one of the things we want to do is explore how OpenSpace in particular joins the dynamic space layer and provides a dynamic ground layer. So typically in operations where we have a dynamic satellite, we have something called a satellite resource manager. And that satellite resource manager is actually in control of the payload and is in conjunction with ground instructions to change the payload based on the design of the satellite payload for the services that are going to be created. Typically, this is also done in conjunction with something in an operational environment called an OSS. That operational support system is joined in the architecture to talk to the software satellite resource manager to make sure that the space layer meets the requirements for the operational services. What OpenSpace allows is to have the OSS layer connected directly to our virtualized orchestration system so that when there are changes in the satellite resource layer, those are communicated either directly through the OSS or may be connected directly to our virtualized gateway services. So what this ensures is that the space layer, the ground system access layer, and the operational systems are all orchestrated in conjunction. So what that means is, as a service provider, if I want to make changes to my satellite, those changes can be analyzed. The changes can be tested in a sandbox, and then I can deploy those sandbox changes to the production environment. What this means is if I change beams or configurations on the satellite, my gateway is dynamically orchestrated to change the configuration of the digital combiner and the digital channelizer to match the uplink and downlink capabilities. That means that we can then use that additional bandwidth or channels to provide additional services. One of the things that OpenSpace can do is deploy either the service chains in a SCPC point-to-point fashion or in a virtualized hub configuration supporting architectures such as FDMA and TDMA architectures for the SATCOM physical layer. So what that does for OpenSpace is allows me in the OSS layer to then deploy a satellite service based on the configuration of the end-to-end service quite easily. The OSS can simply call down into the OpenSpace system and create a virtual SATCOM modem. In this case, I'm showing an SCPC point-to-point modem. But I might as easily be able to deploy a full virtualized hub where I'm doing FDMA star-based architecture. In this case, we would have a shared forward carrier and multiple FDMA returns from our terminals in the network. Each one of these systems and these service chains are fully virtualized, running on COTS-based x86 computers. So therefore, I can dynamically shift the allocation and density of this service as needed. If I need to change the configuration of the service, I can simply send commands from the OSS layer down into the compute base. What's interesting about this, as we look at how we evolve services to our end user customers, is typically the customers are going to be placing orders through a portal. And so we look at how this goes in long term. Customers can create portals that goes through a checkpoint to approve orders. Those orders match catalogs in the service layer. Those service layer attributes match catalog entries in the virtual system. So a customer can place an order for an SCPC service, for example here, and we can check that we have enough bandwidth to provide the service end to end. If, for example, the operator of the satellite wishes to change the configuration to support a particular configuration, they would make that change, the gateway would be informed, and then the OSS layer would redimension the star-based service or the SCPC service on the fly. Then the customer is then able to see the changes in real time and understand what their end-to-end service is. So now that I've shown you how a dynamic space layer and a dynamic ground layer can work in conjunction with each other, let's talk a bit about some of the reasons you might want to do that and what the value of those systems are to your business. So the first thing we can see as we describe the capability is, one, I can have a dynamic service creation. Meaning, if I have a customer that calls me and they want a capability of a system that I may not have today, I can analyze whether my spacecraft can support that configuration in the area of their need. I can dynamically change the configuration of that satellite to meet those requirements. The ground system will adapt to those, and I can then automatically provision those services in the virtual cloud within the OpenSpace platform to enable my customer to deploy that service that they wish. Because we don't always know what the services a customer may need, OpenSpace also provides support for multiple satellite topologies. In this case, multiple topologies In this case, we can, deciding on how the customer wants to run their operation, we can deploy SCPC services or virtual hub services using FDMA technologies or TDMA technologies. The last one is I might want to then take the benefit of those multiple topologies and deploy them and take advantage of the fact that these are not purpose-built or mission-specific hardware components. So specifically, we're able to deploy these dynamic services with our multiple topologies on generic, non-purpose-built, x86, commercial off-the-shelf servers. What this allows me to do is then balance the needs of my network and the needs of my private or public cloud to those services that I need to create. Lastly, these things done in conjunction offer fast time to revenue for a customer who's looking to support services in a new and emerging market or changing their business based on seasonality or changes in demand. For more information about OpenSpace satellite communication solutions, visit kratosdefense.com/satcom.